couple business things. First off, for some reason, good morning. For some reason, the recordings weren't being published on YouTube, so I re-uploaded them and put them all up there. So if you've gone on or if you've missed any of the last 3 classes and want to go back and watch, all 3 of them should now be on the YouTube, including if there's one of them to watch. It's the most boring one, but last week, if you missed last week's discussion of paper writing, it should be helpful on the process of paper writing. So yeah, all those videos should be up on the YouTube. The YouTube is posted to the class Blackboard. Now, second things, you have a paper that is due a week from today. The prompts are on the Blackboard, and as I said last week, so the paper is due on, let me just pull up the syllabus to make sure I don't give you the wrong dates. Should have pulled this up before, but I'm doing it now. All right, here we go. The paper is due on Thursday, end of day, which would be Thursday, the 28th, end of day. And end of day there means 11:59 p.m. Again, as I said last week, if you turn it in after that, just a little bit after, I'm not going to take off points. Also, if you need an extension, please, I would much rather you ask for an extension than you plagiarize or anything like that. So even if it's earlier in the day on the 28th and you need an extension, just reach out and say, hey, professor, could I get an extension for this paper? I'm probably going to give it to you. If you're feeling ill, anything like that, or even you just have other things going on and you would like to have a couple extra days so you can write a better paper, I'd much rather give you that extra time. Now, I'm also going to put up Tuesday, the 26th. Let me make sure that this is also the correct thing. I'm pretty sure I set the date at Tuesday. Yeah, Tuesday, the 26th at 8 a.m. Anyone, what is this deadline? What does Tuesday, the 28th at 8 a.m. mean?
Correct.
Yeah, that's the last time I will accept any drafts you want me to look at. So I'm very happy. A couple of you have actually sent me something already. I read it over and gave it back to you. If you would like to send me something else, good morning, and you would like to give me a draft or a part of a draft or anything to read over and give you full feedback on, and I will give you substantive long feedback. I usually spend about 15 minutes per draft you send me, and you will get sometimes even more depending on how long your draft is. And it will be, you'll have a lot of little red lines and everything and some suggestions on things you can improve. So if you are really interested in writing the best paper possible, I would definitely recommend you get me a draft before this time so that I have time to give it back to you. Do that, and it will help you with the paper writing. One other thing I failed to mention last time. This 3 to 5 pages, that is how long the paper is said to be. I want to make clear, this is a recommendation. And I say this is a recommendation. Basically, what I'm saying is, if you write a 2-page paper, I'm not going to take off points just because it's 2 pages. If you write a 7-page paper, I'm not going to take off points for it being 7 pages. This is a loose guideline, not a hard rule. If you turn in something that's like just the end of 2 pages, you're not going to lose points for it. So don't stress about that. The reason I suggest 3 to 5 is, in my experience, these prompts are generally best answered in somewhere between 3 and 5 pages. If you go under 3 pages, it is very difficult to include the level of detail needed to really explain the concepts and show you understand them. Also, if you go over 5 pages, very often the reason a person goes over 5 pages is they are repeating themselves or including things that aren't relevant. So generally speaking, the best papers usually fall between 3 and 5 pages. That said, I have gotten some excellent 2-page papers that did everything they needed to in a very concise, clear way, and they got A's on them. Also, I've gotten 7 or 8-page, 9-page papers where the person just covered a lot of information and they weren't repeating themselves. They weren't just talking about irrelevant things. So they also got an A. So if you get to 7 pages and you're worried, like, am I going to lose credit for this? Ask yourself, why is this paper 7 pages? Is it 7 pages because I'm rambling? If so, cut some of it out. If, however, you think you have everything you need and everything is good, leave it all in there and I won't take off points. Edgar, did you have a question? I saw your microphone turn on and off. If not, no worries. I just wanted to make sure I wasn't talking over you. All right. No worries. No worries, Joel. All right. So does that make sense, everyone? The 3 to 5 pages is a recommendation, but not a hard and fast thing. All right. Awesome. I just don't, I don't want you to have to stress about word numbers or anything. This also means that you don't have to like include extra large periods or anything to make sure you reach the page limit or anything like that. I don't care about that stuff. Put your effort into the quality of the paper and the focus. So again, paper is due end of Thursday, but if you need an extension, ask me ahead of time. And if you want feedback on a draft, this is a hard deadline. I cannot get you feedback if you send me something after 8 a.m. The reason being that I need enough time to get you your feedback before the paper's due. So if you want feedback, I recommend writing some stuff up this weekend. It doesn't have to be a complete draft. It can be the first part of one. The more you can give me to get feedback on, whatever you give me, I'll give you feedback on. Also, if you give me something today and I give you feedback back tomorrow and you want to ask me again something else, you're welcome to send me another updated draft on Monday. So yeah, that's that. Any questions on the businessy front? Or are we all good? We good? Thumbs up, smiles, whatever. All right. So if we're all good on that, we're going to get to the topic today. So what is our topic today? I'll give you a clue. It's written on the board. What's the topic? Come on. Somebody prove to me you're alive. Yeah, data mining. Thank you. For some reason, also, the chat seems to be slightly delayed, which is why there are extra awkward pauses. I've just realized that for some reason, the John Jay Zoom runs more slowly than other Zooms I've used, which is just like a weird fact. So yeah, data mining is the topic. Now, how many of you had heard of the phrase data mining before this class began? And by this class, I mean this semester. I've mentioned it a few times. Has anyone else heard of it? Okay, good. So many of you are familiar with the phrase. How many of you knew what it was or still know what it is? And how many of you are unsure? If you're unsure, just type unsure. And to be clear, I was completely unsure of this before I learned enough about the topic. Yeah, it's kind of a tough sort of thing to wrap your head around. And like, even to this day, like I have a decent grasp of it, but it gets used in many different ways and it's kind of an unclear term. And it's also associated with a lot of other phrases. Data mining, other things we'll be talking about today are this notion of big data, which is related but not quite the same as data mining. And another thing we'll be talking about is AI, or artificial intelligence, which is again related but not quite the same thing. So the way I think to get into data mining and understand what it is let's just start off, before we talk about all these other things, with just mining. And I mean mining in the strictest sense of like gold mining. What is mining? Or coal mining, or any sort of actual mining that human beings have done through our history? Salt mining, diamond mining. What is mining? Yeah, you dig around in the dirt to find a resource. And specifically though, when you're digging or searching for it. So you are digging for diamonds. Most of what you dig up will be what? If you're looking for diamonds, what are you going to be mostly digging up? Dirt and rocks. And so 99+% of what you're looking for is dirt, which leaves 1% for the gold or the diamonds or anything else you're looking for, the good stuff. So what it basically is, what mining is sorting out large amounts of useless stuff from a handful of very valuable, important things so that you can get your hands on the important stuff. That is the same idea with data mining. what data mining is the act of looking through large amounts of useless, unimportant data in order to find the nuggets or small pieces of incredibly valuable information that are stored within those large sets of data. So, for instance, if I give you an Excel spreadsheet that is 45,000 columns and 40,000 rows, you aren't going to be able, most of that information is going to be pretty useless to you. But some percentage of it is probably going to be very useful. So when you go through and identify the things you're looking for, the important stuff to you, you are doing a type of data mining. You are mining the data for the good information. Now, the reason that data mining is coming up in this class is what? In some sense, we've always done data mining. People have always looked through data to try to find important, good pieces of information. But why are we talking about it in this class? And why is it that data mining has become much more of a topic in the past 25 years? What has fundamentally changed? And this ties into what we talked about 2 classes ago. What is different now than it was the case in, say, 1980? Yeah, technology. And specifically so one thing is it can be a cybersecurity concern, but more generally speaking, it's just that, remember what we said last time, or 2 times ago, if I wanted to store like 25 pages worth of information, like a 25-page long spreadsheet, or say I wanted a spreadsheet with, say, 40,000 rows and 40,000 columns, and it's the year 1980, what would I need to have all of this information? What would I have to have? Well, today I'd need computers, but let's go back farther. Let's go to 1900. What would I need in 1900 to have this? I need lots of pages of paper. I'd need a huge amount of paper. I'd need a room. I'd need boxes. And then on top of that, think about imagine that you're looking for one number in a giant spreadsheet like this, and it's the year 1900. What would you have to do? So this is a gigantic spreadsheet, 40,000 by 40,000. That is like, there's a few million squares here. I think it's a couple million. Yeah, it should be, I can't do math, but I think it's about 1 million different squares. If you wanted to find a particular number in the year 1900 with a 40,000 by 40,000 spreadsheet, what would you have to do? You'd have to manually read through this gigantic, you'd have to go through file boxes over and over and over. Nowadays, if you're looking for a particular number in this spreadsheet, what can you do? If this is now in Excel or this is on Google Sheets, what can you do? Search, and specifically, you just Control F it. So this is one of the reasons that data mining is a much more prevalent topic. One thing is, because it's so easy to store things now, you're able to store so much more data than ever before. So you're able to find new patterns in the data that you wouldn't have been able to before, simply because no one would have bothered storing a spreadsheet this big before computers. Also, because of computers and search functions and the like, giant spreadsheets are much, much easier to use. You can do things that could never have been done in the past without computer technology. So that's why data mining is coming up today. And this is where this notion of big data comes in. The idea behind big data is just large amounts of data controlled by large companies that work with data. So big data is something that's come into existence with the computer, where it's just basically saying the amount of data being stored is huge, and the amount of power that one gets from this amount of data is huge. And so this is the idea behind what just data mining is, looking through large tables of information and finding the good stuff or the important things. And it is made possible by this world of big data, which is the amount of data a person can store and look through, etc., is much bigger than ever before. So does all of this make sense to everyone? Just these basics of what big data is, what data mining is. We all good on this stuff? Any questions at this point? Okay. So now, the reason then that data mining has become so powerful and so useful is one thing it can do is it can start to look for what is generally called metadata. So what is metadata? Does anyone know? And this is part of the reason that big data is so powerful and part of the reason that data mining is so powerful. Have people heard the phrase metadata before? Does anyone think they could give a definition of metadata? Okay, it's like data. It is a type of data. The way to think of metadata is data about your data. That's what metadata is. It's detailed data that's about the data itself. So what do I mean by this? Well, think of it this way. When you and I are, imagine we have a phone call, you and I. What is the data in our phone call? What is the information that's getting passed back and forth? What is the data that is exchanged between us? Yeah, the voice packets. So it's not actually the call length, Justin. It's rather the thing we're saying to each other. So let's say I call you up and I say, hey, Justin, let's get together on Saturday. The data is what we actually talk about, that we're getting together on Saturday. The metadata is things about that exchange. So if we have a call, the call length, the 12 minutes we talked, that is metadata about the call. Who called who? Did Justin call David or did David call Justin? That's metadata. The time we talked at is metadata. So metadata is the data about the data. So it's not what we talked about. So somebody with the metadata about our phone call wouldn't know what we talked about. They just know how long we talked for and who called who and where the calls were taken from and all of these things which are not directly relevant to the content of the call, but are rather a higher level. So it's data about our data exchange. Does that make sense to everyone? Of what this idea of metadata is? Yeah, it's data about data, or data about data exchange, or data about your information. Now, why is metadata important? And why does this tie in with data mining? Well, here's the basic idea behind it. You and I are human beings. We have limited minds, and we are able to think of certain types of things and not others. There are certain things that happen in the world which we would never think about just because of who we are. However, it can be the case that certain sorts of facts still hold true. So what do I mean by this? Well, there are certain types of things which people, so for instance, you might never think of the fact that, so daylight savings is coming up. So the start of daylight savings is usually in the spring. The start of daylight savings is the day that you all lose an hour. When you think of losing an hour, what do you think of? What would you think to look for? Just like you're trying to learn something about daylight savings. What sorts of things would you think might be true about daylight savings starting? Yeah, less sleep. So yeah, that sort of thing. We have less sleep that day. Would you, in your mind, think to look up the suicide rate associated with this day? Would you ever think to be curious enough to look that information up? No, you would never think to. And yet, as a matter of fact, this day right here is one of the highest suicide rates of the year because people have less sleep and are miserable. So if I were to give you just a data set and told you to look through it, you would never think to compare daylight savings and suicide rates. However, a computer could look at all the suicide numbers for the past 50 years, look at what date they happened on, and notice that there's an increase in the number of suicides that happen on the day daylight savings ended. And from this, if you are a suicide prevention company, what you can do with this information is you can then look and see, oh, we should spend extra money to, advertising anti-suicide messages leading up to daylight savings. We should have extra people ready to work the hotlines, suicide prevention hotlines, on the day that daylight savings starts. And why are you able to gain this information? Well, it's not because a human being looked through this big data set. It's rather because a computer was able to mine a large set of data and find this useful correlation between daylight savings and suicide rates. So in this way, the computer is able to find something that a human being would never be able to access. So what data mining basically is allowing a computer, what's changed with it is a computer will sift through gigantic data sets of things that no human being would ever think to compare, and that the human mind would not be able to compare very quickly. And the computer is then able to recognize patterns like daylight savings and suicide rates, or things like area codes and college acceptance rates, and things like that, or area codes and likelihood to own a Ford. These are the sorts of things that a human being would never think to look up, but simply by comparing the data sets, there might be patterns there that we don't recognize. And if a computer recognizes this pattern, it is then able to use this information in certain sorts of ways. So does that make sense to everybody about just generally how this sort of thing works? And how using this mining technique, just looking through these huge data sets, will allow you to gain information that you might not otherwise have had. Mine the information, and that information gets mined by a computer whose job is just to look for patterns. All of this makes sense to everyone. We all good? Everyone say yes if you're alive. Or say no if it's not making any sense to you. All right. So that's the first bit. This is the general overview of data mining and how you can see, why does this tie in with metadata? Well, once you have the metadata, you can do the same sort of mining on metadata. You can start to find patterns within the data about the data. So it's not just that you're able to find patterns that no human was able to find. You're now able to find patterns within the data that's about the data that no one would think to look at. So you can see how exponentially this is getting more and more powerful, and more information is becoming available. So what I want to do now is just to hammer this idea home. What I want to do is just show the idea of why data mining is so powerful. And basically, when you're having a computer data mine, why the computer is able to do this. So basically, the key with data mining is that makes it different from human beings is human beings, to make some sense of data, very often have to know what the data is, like what the numbers correspond to make any sense out of it. And so we don't really know what to do with the data. A computer, by contrast, can just look at these patterns, see which ones go up, which ones go down when other ones go up, very quickly and easily, and from there start to draw conclusions. And once those patterns are recognized, a data analyst, a human being, can look at these patterns and start to think, what could we do with this sort of information? So I literally want us all to put our heads into what I'm going to ask you all to do is become data mining computers with a data set I'm about to share with you all. What I want you all to do is look over this short. It is 5 columns, or 7 columns by 5 rows. I'm going to share my screen, and I want you all to look at this and just recognize patterns between the numbers. So what do I mean by this? Well, if column B is high and column G is low, And each of the numbers, every time column B goes up, column G goes down. That's the sort of pattern I'm talking about. Or if column A goes up, and whenever column A goes up, column B seems to go up, that's another sort of pattern I'm talking about. So this is what I'm trying to point out. It's just, I want you all to look at this data set and see the sorts of patterns that we're doing. And once we do this, what I'm going to do is we'll talk about what this data is actually corresponding to show how what a computer would be able to do quickly, much more quickly than us, just recognizing this pattern, can then be taken by someone who knows what those numbers mean and draw conclusions that could then be used by companies, by individuals, by governments to make decisions. So does that make sense, everyone? What we're going to do, I'm basically going to show you a data set, and all I'm asking you to do is just look at this data set and look at relationships between numbers. See if you can find things where if one number goes up, the other goes up, or if one number goes down, the other number goes down. That's all I'm going to ask you to do for the next couple minutes. Does that make sense to everyone before I share this screen? All right. So can everyone see this? It should say data mining and just have columns A, B, C, D, E, F, G. And then it starts with 1, 0, 0. Okay, good. Now, talk to me about this data set. Just look at it. I'll give you all about a minute and just type in the chat or say out loud anything that you recognize about any of the relationships between these numbers. And I'll do the same. So first off, is this an easy task for you to find these patterns? So the first thing to do is, well, Kevin says, no, this is not easy. And I agree. This is not an easy task. This is tough for a human to look through. B and C column 1 and 2. So what are you, Sammy says B and C column 1 and 2. What pattern do you see here, Sammy?
When B is like 21, C is 81, and then it's the other way around, kind of like the numbers are kind of close.
Yeah. So yeah, these ones, there's a big difference here, but the other numbers are kind of similar. So that suggests something that is here. So yeah, Shad says it's not easy because there are no references. And that's exactly the point. When the numbers on the left are lower value, the numbers on the right are greater value. Wait, Daniel, which columns are you talking about? Column B and C. When the numbers on the left are lower, the numbers on the right are greater. So yeah, this one is quite low. This is quite high. This one is quite high. This one is quite low. This one's middle. This one's in the middle. This one's very low. This one's very high. This one's very low. This one's very high. So exactly, that's a really good one. This is the sort of thing where like you can recognize as this one goes up, this one goes down. Let's compare C and D. Look at C and D. What's the relationship here? It's similar to the example that Daniel just gave about when one changes, the other changes. But what's the relationship exactly? It's not a perfect relationship, but it's pretty strong. So for instance, which of the 4 rows or 5 rows is well, which of the 5 rows is the lowest number in C? Is it 1, 2, 3, or I guess it's 2, 3, 4, 5, or 6? Which is the lowest? C3, yeah. And now look over in D. What's the lowest? The 3rd. Which is the highest? And the second, or I guess, what's the second lowest in C? In C, yeah, in C, it's number 1, or no, it's C2 or the first row. And then the second lowest in D is also this one. So you can see, generally speaking, the lower a number is in C, the lower, or the lower the number is in D. I mean, there's a slight difference here with these ones, but they're close enough together that it's not a huge difference. Now, right here is basically these patterns here. We are human beings who, if we were to find out exactly what these patterns are, it would take us a very long time. By contrast, a computer could spit out a number in a fraction of a second of what the relationship what is the relationship between C and D mathematically speaking? And what is the relationship between B and C mathematically speaking? And that information could then be used very, very quickly. Now, what is the difference here between a computer doing it and us? The computer's much faster. So what I want to do now is compare that even when we have the data of what this information corresponds to, it still takes us a little while to draw conclusions. Well, by contrast, a computer could spit out these mathematical conclusions very quickly, and then someone who saw these things could then draw conclusions from it. So what I want to do now is just pull up the same chart with what each column corresponds to, and then talk about how, once we know what these are, we can draw conclusions very quickly and talk about the ways in which these conclusions could be useful to us. So basically, what we're about to do is going to be the job of both the data analyst and the data mining software. And we can see that with those two things, a person can have a lot of power. And this is going to be an approximation for what a data analyst is able to do when they are given a data set that has been analyzed by a piece of data mining software. So actually, out of curiosity, can anyone guess what any of these numbers stand for? First off, what is A? Anyone have a guess of what A corresponds to? So it's a label, but what is this labeling? Think in your life, where is there a 5-digit thing that is just a number which stands for something? A zip code, exactly. This over here is a zip code. Given that this is a zip code, can anyone start to guess what the other numbers are? Anyone have any idea what this is? So you are correct that one of these is the amount of people that live there, and I'm pretty sure that is B. Yeah, this is the population, the number of people. Then one of these is income. Can anyone guess which of these rows is the median household income corresponding to the zip code? So it's not D. You're very close. It's actually C. C is the income, and then D is the average house price in that area. This one is, here, I'll just scroll down then. This one here is the density. So how many people per square mile is column E. F is the number of square miles in that area. And then the last one, the percentage, is the percentage of households that have children. So can you now, looking at this data with the labels, begin to see some patterns that you weren't able to see before? So what are some patterns that you can see here? Yeah, income corresponds with how expensive the house is. That's exactly right. Look at columns C and D. Basically, the more money a person makes in a year, or the average person in an area, the more money they make in a year, the more expensive the houses in that area are. Pretty much because they can afford more. Yeah, basically rich people live in the most expensive zip codes. And then also there's less population where there are expensive houses and where there are expensive incomes. Why is that the case? Like, just thinking about it, that right there is a description. Anyone out of curiosity, why would that be the case? It's pretty straightforward, of just the sort of thing that common sense, if you think about it, you'll be able to tell now that you know what these stand for. Why is it that the most expensive houses have the smallest populations? There's not a lot of rich people is one, but also the 1% can afford a larger. It's not just that larger or rich people afford more expensive houses. More expensive houses are larger and you can fit fewer of them in a certain area. Now let's look at this one here, 10002. This is the most populous and also the poorest by median income and has the least expensive houses. So actually, I think this number is wrong. I think this should be even higher. I put this one in wrong. But also then, what else do we find? Look at the median income and look at the percentage with children. What does that suggest? Who has the most kids? Yeah, more money, less kids, generally speaking. Rebecca's exactly right. So what does this suggest? Well, it suggests that these lower income families have more children. So these are the sorts of patterns that you can begin to identify. Now, let's take a step back now. This thing took us a little while. This took like 15 minutes to look through the data and start to find patterns. Now, a computer would be able to very, very quickly identify these patterns more quickly and more accurately than we could. And it would just spit out a number. It would say that column D, when column D rises by 1, on average, column G goes down by 0.3. So that's the sort of thing a computer could give you. And then as a data analyst, what you could do is see like, oh, the median income is correlated with the median house to this extent. Therefore, I can start to draw conclusions and things. Now, what could you do with this data? Think about how this sort of data mining could be used. What could somebody do with this and who would do that thing? So basically, just to give an example, what is some information that a politician might be able to use just from this data set? So one thing is create connections. So say a little more, Joel. What sorts of connections could be made? How could you use this to make connections? Because you're 100% right. But what sorts of connections could be made or what sorts of things could be done with this data? And I want some concrete examples here. So for instance, so it could be used to promote their campaign to target individuals to vote for them. So for instance, let's actually imagine that. If you were advertising in zip code 10005, what could you do with this information? What sorts of things might you talk about in your advertisements in this area? So you talk about things that would increase income, or more importantly, you would talk about things that would appeal to people in that area. So Sammy said low tax rates, and specifically low tax rates for who? If you wanted to appeal to people living in 10005, who would you want to? Yeah, you'd offer tax loops for the wealthy. Daniel says Soul Cycle. Exactly. If you were Soul Cycle and you were looking to start up a new business, where would you put it based on this information? What area would you put it in and where wouldn't you put it? You'd put in 10005. Where wouldn't you put it? Not in 10002. Exactly. Now, if you were opening a store that sold specialized in basically not designer baby stuff, but just like everyday like diapers, of reasonably priced diapers in bulk, tissue boxes, these sorts of things, where would you sell it? Exactly, 10002. Here's another one. If you were a bank and you were trying to put out a loan, where would you? Yeah, you'd also in 10002, you'd put lower expense, like lower price food places. If you're trying to sell high level like restaurants, you wouldn't want to set up your restaurant in 10002 because your customer base would be much, much smaller. So what then, if you were somebody who was, say, I just lost my train of thought. I completely forget what I was going to say. If anyone remembers what I was saying, let me know. But so we've got a soul cycle being the expensive place. The baby stuff with lot would be in the one with a lot of children, and specifically the low price baby stuff. Oh, this is what I was going to say. If you were a police department and you were interested in ensuring that you were stopping the most possible crimes, where would you put the most police? Simply based on the fact that more crimes are committed where there are more people around. Yeah, you'd put it where there's a lot of people. So where would you put the most? You'd put them exactly in 1002, which is Chinatown. Now, what, however, is the possible side effect of this? You are now putting the most cops for exclusively a population-related reason in 10002. But what also is the possibility here? So yeah, Daniel says more discriminations and racial profiles. So as a matter of fact, 10002 is also happens to be Chinatown. So what you can begin to see here is by just looking at these data sets, you can start to make decisions based entirely on this information. But sometimes the decisions that are getting made off of these numbers can start to have downstream effects that you might not think of. So somebody living in Chinatown who suddenly sees a large police presence, this is going to be suggestive of something more. So if you only decide to increase police presence in this area because of the population, without thinking about other factors, it will be seen, as Joel says, as a racial thing. And this is one of the big worries, and we're going to talk about more with data mining, is data mining is incredibly fast and incredibly effective for getting information out, but the data set only takes into account whatever's explicitly written down on it. So if I hadn't told you that 10002 includes Chinatown, and the only thing you were thinking was, I want to put the cops in the area where there's the most potential crime, and there's the most crime in the areas with the most people, and I choose to put people here in 10002 without taking into account things like race, then the decisions that end up being made can be blind or oblivious to things that have these big real world concerns. So this is one of the threats with data mining, is you can start to, if you're making your decisions off of these big data sets, you're sometimes ignoring things that you pick up on, things that a human being wouldn't pick up on, namely the number of the correlations, but you miss out on things that any human being would pick up on. So any human being looking at this data set would recognize increasing police presence in Chinatown has the potential to cause problems, because to a human mind, it will seem racial, even if it was not intended. And the fact is, by ignoring the race of the people there, the system is to some degree racially ignorant in a way that you wouldn't want a person to make this decision. So does that make sense to everyone? How, in the one sense, data mining is very powerful and very useful. But on the other side, it can cause problems because the computers won't pick up on things and will end up causing problems because they don't pick up on things like race explicitly if it's not programmed in to begin with. Does everyone understand that sort of issue? Now, here's another one. If you were a bank and you were giving out a loan, so how do loans work? And I mean this in the most general sense. How does a loan work? Let me stop sharing for a second so we can discuss loans, because this is one of those things that I think we all understand generally speaking, but sometimes we don't actually pause to talk about exactly how a loan works. So if you apply for a loan from a bank, what does the bank get out of it? Why do they give you the loan? So basically, yeah, if you get a $1,000 loan, how does that work? You go to the bank and you say, I'd like $1,000 in a loan form. What do they give you on the spot if they agree to give you the loan? They give you $1,000, exactly. They tell you you will get here $1,000. Now, what do you have to do in exchange for them? They give you the money up front, but what do you have to do in the long term? As Joel says, you have to pay back with interest. So let's just say that it's a 0.1% or 0.1 interest or a 10% interest. What this means is over the course of, say, 5 years, you have to pay them back a total of $1,100. So up front, you get 1,000. So if you have to buy something in the immediate that costs $1,000, you can do it. But in the long term, the bank makes more money than they gave you in the first place. However, for this to work, what do you need to be able to do? For it to be a good investment by the bank, what do you need to be able to do each month? The bank gave you $1,000. Basically, they invested in you. What do you have to be able to do each month to make it worth it to them? You have to pay them back. You have to be able to pay, or let's just make it simple and say it's a 10-month loan. So what do you have to be able to do? You have to pay $110 a month. If you can't pay the bank $110 a month, the bank is losing money. They gave you $1,000 and are getting nothing back. So in order to make it worth their while, you have to be able to pay them. So because of this, do you want to give a loan to someone who doesn't have a job and has no income as a bank? No, exactly, Carlos. Why don't you want to give money to someone without a job? They're going to run away with it, or they're not going to be able to pay you back. Exactly. If, however, you give a loan to someone with a lot of money, is it likely they're going to pay you back eventually? Yes, exactly. Now, let's go back to our sharing chart. If you were a bank and you had to give a loan to somebody and all you knew about them was their zip code, who would you be most likely to give this loan to, and who would you be least likely to give it to? All you know about this person is their is their zip code. And you have these you meet someone and they say, I'm from this zip code. You don't know what their job is. You don't know what sort of house they live in. All you know is their zip code. And then you have these general statistics about these zip codes. Who as a bank would be the best person to give a loan to, and who would be the worst person to give a loan to? So the best are exactly the financial district ones. You'd want to give it to 10004 or 10005. Who would be the worst to give it to based on these numbers? So yeah, any of the ones with a low population and a huge income. And the worst, again, would be 10002. So here again, what is this issue then? The bank has now determined, based entirely on your zip code, whether or not you're a good financial investment. What are the problems with the bank doing this? I see a couple different problems. What are the moral issues here? Like for the bank, it makes complete sense. But if you were somebody who lived in 10002, what issues with this would you have? So yeah, unequal opportunities. There's just the fact that built into this system is the fact that if you have a lot of money, it is easier for you to get more money. So that is one major issue here. Of if you are a person who already has a lot of money and you live in 10005, getting a loan to start a business is going to be very easy for you because the bank is going to be looking at these general statistics when making their decision. If by contrast, you are someone from 10002, it is going to be much harder for you to get a small business loan because the bank is going to deem entirely based on your zip code that it is going to be more difficult for you to pay it back. So that is the one thing, is unequal opportunities. What are some other ways in which this is a problem? What are some other issues here? This similar to the one with the police situation. who is getting these loans and who is not getting these loans? Based on what the neighborhoods are, who lives in 10002 and who lives in 10005? We've already said wealth things, but think racially. Yeah. We are now, in some sense, without, like, basically what this is leading to is if you are Chinese, you will not get a loan. And if you are white and living in the financial district, you will. You are now, in some sense, without it being just by going on the numbers, loans are now being done on a somewhat racial basis. Without that, I mean, granted, the bank would never say that's the case, but in essence, there is now a strong case to be made that part of the reason that these people aren't getting a loan is because entirely based on where they live. Also, now, if the bank is making its decision on these general statistics, imagine that you are somebody who is very wealthy and you have paid your taxes and your loans on time for your whole life. You've never missed a credit card payment, but you happen to inherit a house in 10002. Are you going to be as likely to get this loan as somebody who makes the same amount of money in 10005? If the bank is partially basing this just on where you live? No. So it's now the case. And is this a problem? What is the worry about this? Why is this an issue if the bank is making the decisions off of these big numbers and big data sets? Yeah, it's unfair. How many of you want your well-being for a loan to be decided based on how much money your neighbors make? How many of you feel that that's fair? That your credit card payments and everything else is going to partly be determined by how well your neighbors pay their credit card bills? Should that affect it? Not at all. This, however, is what can happen when you start doing this sort of data mining. And for those of you who 2 classes ago were saying privacy stuff is not as big of a concern, well, part of the reason why privacy is a big concern is that these sorts of data are the sorts of things that used to be somewhat private, but thanks to modern technology and big data, are now somehow open to companies to use. So it's not so much a problem that they are going to target you as a person in these cases. It's rather that because they have access to all this information that used to be private, they can now create these large data sets and use those large data sets to draw conclusions about entire populations of people and then make decisions based on these sorts of things. So does this make sense to everyone of what is the case, like what is this data mining thing? And why is it that we're able to, like, how is it that gathering data about particular individuals can then be put into these big data sets and then draw these big picture of the conclusions that from a business standpoint make complete sense? But from a personal level standpoint, from a human being standpoint, looking at it, we can start to see that, oh, what ends up happening is racial stereotypes and racial prejudice get built into these computer systems and computer models, where why was it originally the case that the people in Chinatown ended up with lower income? Why was it originally the case that it, like, as a matter of fact, why was it that you ended up with large numbers of Chinese people living in low income neighborhoods in the Lower East Side? Historically speaking, what led to that fact? Why was it that all the people of Chinese descent were kept in that one place? There's a few different reasons, but can anyone guess what one of them was?
It's discriminate?
Yeah, discrimination or gentrification is probably part of it. But generally speaking, if you look at American history, it is just full of racism. And that's the fact of the matter. So part of the reason in which why did so many people of a certain race end up clustered together in a certain neighborhood was because of, like, why did Chinatown come into existence? Part of it is that, you know, people like to live around other people with whom they have commonalities. So part of the reason that people ended up together in a certain area is that people who had all immigrated from China clustered together partly for reasons of we want to be amongst other people with our backgrounds. But another reason was that people of a certain background had less opportunities in a more racist era. So for instance, why was it that Black people were kept in Harlem? Well, part of it was that if they went outside of Harlem, they were discriminated against. So this meant that we had large numbers of Chinese people in 10002. Because of this and the discrimination, it now led to the case that 10002 has a low income compared to some others. So we'll say low income. And now the fact that 10002 has this low income is now making it harder for people who still live in 10002 to get loans. Loans hard. So we have this weird thing in which, because originally this racism happened, it will then lead to lower incomes. And now, even if we aren't looking at this through a racial lens, there's a sense in which, and when people talk about systematic racism, this is the sort of thing they're talking about. It starts off with a racist situation, which leads to lower income, which then leads to less opportunities. And it all goes back to the ways in which, even if the person in the bank is not explicitly racist or trying to be like, I hate people of color, the fact is that their computer programs in this way are being discriminatory in ways that historically trace back to this. So does this make sense, everyone? Some of this is going to be the sort of thing where it's like, yeah, no shit, professor. But some of you, this might be something where it's like, and at least the mechanism might be something that's different. Also, there's the, I mean, and granted, like, just to put the cards on the table, there's also something like the same mechanism here of the systematic racism. Like, I want to put on the table, I am fully aware that the fact that I am in front of this room right now, part of the things that made it easier for me to do that is these same sorts of systematic racist things. So I don't want to just like, and so there is something also, this deep irony or trouble here of I being the one talking about this to a room full of people of color, which is itself something that I would be happy to talk to anyone about at any point. But this is the way in which computer programs, which were designed to get rid of racism, like a computer is not in some sense racist, can still institute these same sorts of racial policies without actually intending to. Does all of this like conceptually make sense to everyone? And so can you begin to see again, why is it that we should care about our privacy and all the data out there? Well, it's not so much because you individually are going to be targeted or followed. It's rather that because all of us are giving all of this data, these sorts of computerized systems are very difficult to work against, or they come into existence and are able to be instituted because of this loss of privacy. And here's another issue about one of the ways in which these things are so sinister. If somebody, so imagine you have a landlord, and your landlord is racist, and you try to get a loan, and or you try to renew your lease, and your landlord says, no, you can't redo your lease, and it's pretty clear that they are doing it entirely because of your race. What can you do now? If your landlord discriminates against you and refuses to give you a lease because you are a person of color, you can take legal action. You can sue. If you go to the bank as a person who lives in 10002, and you go to them and you say, I want this loan, and they say, no, you're high risk. And what can you do in this case? What can you do to say, I'm not low risk? Are you able as easily to say that this bank is being racist against me or this bank is discriminating? You could, but is it going to be as clear cut of a legal case? Yeah, exactly. It's a much less clear case. The bank is going to say, we are not doing this because of your race. We're doing it because of where you live and what we deem that to be. So what you have here are ways in which, when things get computerized in this way, it can become a lot more difficult to recognize the discrimination that is built into the system, because these things are not explicitly the case. So to give so is everyone on board with just this general sort of picture of how this works, how this functions, everything like that? All right, let's now bring up our next thing I want to talk about, which is basically AI. What is AI? What does it stand for?
Artificial intelligence.
Yeah, artificial intelligence. All right, what is AI? And this is something that's tough, because the way the phrase AI gets used, it is a very broad term, which gets used for many, many different types of things. So when you think about AI, what do you think of? And there's not a wrong answer here. What sorts of things do you think of when you hear the phrase AI? You think of Siri. That's a good one. What else do you think of? Echo, Siri. I'm just going to put all of these sorts of like talking things. Alexa. You can also think of self-driving cars. What else can you think of? Ex machina, exactly. These ex machina or sentient robots. What else do we think of with AI? Anyone have some other things? So these are typically the sorts of things we think of with AI. And what is it to be artificial intelligence on this definition? Or what do all of these things have in common? What is it that makes a self-driving car like a Siri, like an ex machina robot? Yeah, it's just about human type thinking. So what AI basically is it's just a phrase for computers doing tasks that humans typically do. And this is why it's such a broad case, because the types of things we typically think of as AI are very high-end fancy things. So they're things like sentient robots who are aware of themselves and doing complicated tasks, or they're cars that are driving themselves, or they are Siri, or they are Echo, which are talking or something like this. But by this definition, AI also includes a lot more mundane, simple sorts of things. So what goes under the characterization of AI now includes such things as just decision-making tasks. Things like, should we give this person a job? This right here, if carried out by a computer program, is going to be, we will say that is AI. Deciding whether to give someone a job is a classic human sort of decision carried out by a company. But now decisions like this are very often being carried out by programs whose job it is to look at the application or the data and spit out how confident this machine is that we should give this person a job. So given this very general definition of AI, of just a machine that does something that humans used to do, including decision making, what are some other areas in your life or in the world in which AI would be operating? And there are infinitely many. Just think about things that a computer are computerized now, that we can think that the computer is somehow drawing on data sets to make a decision. Right now, we've got, should we offer this person a job? What are some others? Online tests. So what sorts of tests, Justin? You're spot on, but what sorts of tests are you thinking about here?
I'd rather like explain it. I was just thinking of like, like regular tests, like on Blackboard, you put in an answer, it checks if it's right or not.
That's exactly right. That is a type of AI. Even the stupid BuzzFeed quiz of what type of dog are you, that is in a certain sense a simple AI program. You put in answers, it spits out how well you scored. But so these sorts of ones are really simple, but there can be more complicated ones as well. Things like you could program an AI test to do something like, how likely are you to commit a crime? That is something which could be carried out by an AI program. You'd program it with what sorts of things. And so this is the key thing with AI is an AI program will basically look at a large data set and then spit out a decision or a percentage of how likely something is, or how good something is, or how bad something is. So the idea here is that the program will automatically make the decision for you. So instead of having a human being, and job hiring and college applications are another big thing that are open to AI or data mining sorts of things. So machine learning and AI are entirely overlapping in a lot of ways. You can think of AI as the broader term, but machine learning is a type of AI. And so what machine learning is a case in which you don't program the actual algorithm that it uses. Rather, you give it a starting algorithm, and then based on how well it succeeds or fails, the computer teaches itself further how to do better in the future. So, so machine learning would be a case in which, say, I'm trying to teach a machine how to, here's the way to think of it. Machine learning is basically the way in which you train an AI program, or one of the ways. So to use this notion of facial recognition software, which is another type of artificial intelligence. And I think we talked about this one a few classes back. So basically, here's how facial recognition works. And this is why this is going to tie in with machine learning and with AI. So what you initially do with a, as I said a few classes ago, you give it a face and it finds certain sorts of points on that face. And then based on the lines between these points and the distances and everything, it will then the computer will recognize, is this the same face I'm now looking at? And so what you initially do is you program the computer to make a decision of, yes, these are the same, or no, they are not. So this right here, this decision, same or not, that is the AI decision right here. That right there, the facial recognition decision, yes, this is the same person, no, it is not, that is done by the AI program. And what will happen is a programmer will initially set up a baseline test in which the thing is programmed simply to do this sort of thing. Now, this is where machine learning comes in. So basically, what you do to teach this machine to get better at it is what you do is you have a separate thing, usually a person there, who judges how well the computer did on this task. So if this person is the same person and the computer says it's the same person, you have someone who then says, yes, this is the same. You got it right. So then the AI person, trial 1, good. Then trial 2, it says these people are the same, but to the human eye, it's clear they're different people. You tell the computer, bad. And then it uses this fact that it got it bad to then try again later and try a new method of doing this. And so what the machine learning is basically you take the success or failure of the outputs, feed them back into the AI system, and then that AI system improves upon itself in a way that, so instead of having to have a programmer come in and fix it over and over again, the program in some sense learns on its own by telling it, yes, this is the same, no, it isn't. Or what you can do is you give it a set of 2 pictures and you specify in the learning mode, this is the same person. And so the machine first gives it gives the answer not the same. This not then gets compared to the actual answer. You learn the machine got it wrong. This then gets fed back into the machine, who looks at its initial algorithm, which led to the answer not the same, changes it so that the next time this comes up as yes, the machine then says, yeah, like the training program then says, yes, you succeeded. And now the AI program has improved upon its initial thing. So that's what machine learning is. And that is a sub-program within AI itself. But not all AI programs are machine learning or self-taught in this way. Some of them are just completely programmed by a human programmer that then the AI takes over. And the only way to improve the system is to have a programmer go back in and change the program around. But this decision-making task, this still counts as AI. Does that make sense to everyone on the short little AI machine learning tangent? And yeah, I agree, this stuff is fascinating, but it's also deeply troubling in certain sorts of ways, because what can begin to happen is that, well, who is responsible for so an AI program doesn't just come into existence. The thing that decides on your college app, it's not like you just have it come into existence. Who designs the program that calculates this? Who designs the AI? Humans do. So yeah, all of these things, the way to think of how AI works is you start with a human programmer. The human programmer writes an application, a decision-making app, basically. And then the decision-making app makes all the actual decisions. So it's basically the way in which you save time as a company. If in the old days, the way it would work with college applications is, say you get 1,000 applications in the year 1950. You get 1,000 applications. How would these applications to say John Jay be sorted in the year 1950? What would go on?
Like they would look at them manually, like one by one.
Yeah, you'd have to have a group of human beings look over all 1,000 applications one at a time. So every application got attention, every application was sorted through, and you'd have to do this every single year. So you just look at these 1,000 applications and just have to go through them every single year. And actually, because John Jay is much larger than this, you're getting a lot more than this many applications each year. But you'd have to do this every single year. What is the advantage of using an app or a decision-making program to do this? Up front, it's going to take a lot of work by this programmer. But if it works well, how many people do you need to now run this application sorting process? You basically only need somebody to hit start on the computer. It's much, much more efficient from the school or from the company's perspective. So you now have a person who is sorting through, instead of having people sort through 1,000, you now have a computer program, which basically can just, and very often how these things work and how job applications work is you will have an AI program that will sort through so say you get 1,000 applications, the AI program will just automatically, based on some numbers, decide like, this person only has 2 years of experience. Therefore, they aren't qualified for this job, throw them out. This person didn't get a 3.5 GPA, we're uninterested. So in this way, you get down from 1,000 to say 300 that actual humans have to look at. So in this way, the computer takes away a lot of the work. And this is how this sort of artificial intelligence data mining sort of thing works. is the computer program will sort through in large numbers in a way that wasn't possible before. But now, so this is everyone on board with what this idea of AI is, how it's supposed to work. A computer designs a human designs a program, which then makes these human decisions for you in areas like job hiring and everything else. Any questions at this point on any of this stuff, or concerns, or any of this? Anything at all? We good? All right. So, given all of this, this is the basic idea. Where do the problems start to come in? There are ethical questions that come up with these sorts of things. What are they? What are the ethical worries, the ethical problems? And I can think of two major ones that I want to highlight. But can anyone think of problems when we have these AI machines making our decisions for us? Yeah, just work through here. What are some things that you can think of? So one thing Kevin says is it doesn't take into consideration a lot of factors. And that is one of the major issues here, is only look at what it was programmed to do. So here's an issue. Yeah, any computer, it only does so yeah, the humans being taken over by the AIs is downstream. But let's think about this. All right, how many of you, imagine I wrote an AI program that says due date 8 p.m. and you turn in your paper at 8:01. What would happen if the person deciding whether this paper is acceptable or not is an AI program that has just decided 8 p.m. is the due date? And it takes off a point, or it takes off 10 points for every day late. What will this AI program deem to be the correct score you should get? So imagine you write a 100 paper, but turn it in at 8:01, and the policy is, say the policy is 10% off every day, and you got a 100 paper, but you turned it in a minute late. Yeah, bye-bye 10 points. Now, it's automatically 10% off. Now, if this happened with me, think of a reason. What's a reason that you might turn in your paper 1 minute late? Slow internet. And if you approach me about that, what am I likely to say? If you say, I'm going to say, oh, it's okay because I know what slow internet is. Or imagine you've been sick for 3 days and you have a doctor's note that says you've been sick. Well, in this case, what am I going to say here if you say I've been sick and you show me a doctor's note? Where are those 10 points that just disappeared? Where are they going to go? Right back where they started. Exactly. Interacting with a human being, we can take into account a lot of these different things because of the human mind might not be as good at picking up patterns in data like a computer, but our minds are much more flexible and can draw on many more different things. Computers, in a certain sense, don't have what we would naturally call common sense or an ability to see context. But so by contrast, if you tell this AI program, my internet is slow, what is the AI program going to say? And it's not even, Kevin says not much. It's not even not much. It can't even compute what you're saying because it doesn't deal in these things. All the thing is able to do is a binary. If it's past 801, you lose 10 points. It cannot take into account context. It cannot take into account any of these sorts of things. So this is an issue with these sorts of AI decision-making programs, is it will not take into account context. So how many of you have had to call up Time Warner or Verizon or whatever Time Warner is now called, and it takes you fucking forever to find a human being? And because of this, you spend an entire afternoon on hold. How many of you have had this experience? I certainly have. Have you ever wondered why the hell is it so difficult to speak to a person? How many of you have had the experience of why the hell is this so difficult?
Because you have a robot trying to figure out what you're calling for.
Exactly. That's the major issue, is there's an AI program in a certain sense that is designed to save them. Part of the reason is demand, Joel, but another reason is they basically, for monetary reasons, a lot of their calls are taken care of by an AI program. And if your problems fall into one of their like 7 boxes of things that can go wrong, then it's very, very simple to like the computer will make it go faster if you're using an AI program and things fall into a box. The issue is the nature of the world is such that things come up which people who were programming the thing did not take into account. So if you're wondering, why is it the case that when you call Verizon and your issue is something that's not on their list, no one knows what to do? Well, it's because the AI program is only programmed to deal with a very specific set of issues they have, and you are approaching them from outside of this. So AI decision-making is incredibly inflexible. So for instance, if like one thing which is making it harder for, so basically an AI program is programmed in like the job application sense. It will basically throw out applications that don't fit its guidelines for what a good application is supposed to look like. So if you've had an extraordinary situation happen to you, so for instance, imagine that you were on pace to graduate college in 4 years. However, let's go back to, let's imagine there's another hurricane and your house floods. Everything gets broken and you have to spend a year helping your parents rebuild your house. And now it takes 5 years to graduate college. Well, an AI program that is designed to check, is this person reliable based on how many years it took for them to finish college? What are they going to do to this person who took 5 years to finish because of the fact that their house was flooded by a hurricane? What is this program going to say? Who is it going to vote higher on, the 4-year or the 5-year? Who is going to be a better candidate just from this data? All it knows is the number. So why? So think of it this way. Let's actually zoom back a bit. What is, I need to put this in context a little bit. Generally speaking, companies want people who once they start something, finish it. And generally speaking, if somebody finishes college in 4 years and they finish it exactly in their 8 semesters, that is generally a pretty decent sign that they are reliable and stuff gets done. Oftentimes when people take longer, it's not always the case. And to be clear, this should not be the conclusion, but sometimes the reason that it takes someone 5 years is because they were fucking around for one of them and they failed a bunch of classes. So if a person is just looking at this and all they see is 4 or 5, you might think like, oh, the 4-year person has their shit together, the 5-year person maybe doesn't. And this is something which can actually, decision-making processes can be made by humans. Now, if you were in a human job application and you were this person whose house flooded and the person you're speaking to says, why did it take you 5 years to go to college? What would you say to them if you were the person whose house flooded? What would your story be if they ask you, why did it take you 5 years? You'd explain the financial issues in the house flooding. And as a human, what are they going to say in response, probably? How are they going to feel about a person who took a year off college to rebuild the house for their parents? How would, if somebody was applying to you for that job, how would you feel about them? Would you think they are reliable? You'd think that's understandable. And not only that, if anything, you'd have a good feeling about them because they helped out their parents in a time of need. You'd have empathy. By contrast, a computer program that only looks at the number will in no way be able to have this sort of context. And in this way, it's going to basically, extreme circumstances that are out of your control, if it's judged by an AI program, will often be held against you in a way that you can't work against it. You can't appeal to the computer program. The computer program is only going to spit out like, hey, this person is a 7 out of 10 score. This person is a 7.5 out of 10. Therefore, this is the better candidate. And this is all that somebody will see. They won't know. And this is another issue with AI programs, is the person who looks at the numbers, generally speaking, is not a programmer who has in any way knows what goes into this calculation process. Very often, how these numbers get calculated is very, very hidden by the company who designed the program. So if you buy this program, say you're a company and you use a program that you buy from a third party and you don't understand how it works, all you see is the number that gets spit out. If you feel that this company is treating you poorly because you had to spend this year fixing your family home, that's not something you can convince a company who uses this AI program to take into account. So one of the major issues with AI programs is that using them to make decisions, they can ignore the context. They end up making decisions that are not in line with what a human being or common sense would say. And if you've had an abnormal route through your life, these sorts of AI programs can sometimes discriminate against you, and there's nothing you can do about it. Does all of this make sense to everybody? And this is another one of the reasons where this is kind of a trickle down from how much information of ours is out there in the world now. So people can get all of this information from your online presence, et cetera, et cetera. All right, a second reason. We said, who designs many of these AI programs? And note that I use the word who there. Who designs the AI? As we said, there's some that teach themselves, but usually it's engineers, software engineers. And what types of things are software engineers and software developers? And I don't mean this in like what sort of characteristics. I mean, what sort of creatures are they? What species are they? Humans. What do we know about humans? Are humans perfect? No, humans are not perfect. We are flawed. And so, contrary to belief, if the AI program is being built by a flawed human, what might the program itself end up being like? The program itself might be flawed. So another issue with AI is that they can build in biases. Or if the programmer makes a curious decision, or if the programmer doesn't take into account every factor, then you can end up with an AI program that spits out bad information. So a classic case of this was an AI program the other year, AI designed to distribute health equipment and money to most needy. So you are trying to the design of this program was a noble cause. It was a company that was trying to identify where the most money needed to go for unhealthy people. Their goal was to do something noble in which they wanted to make sure that the places that needed the most health care got the most health care, and the places that needed the least, nobody was wasting resources on it. And the way they did this is they got a data company, basically an AI programming company, to design an app that would be able to assess how much this will be. And basically what they did was, this app was designed, you put in a patient's data, and it would predict how much money is this person probably going to need in healthcare, therefore that you, the hospital, could make sure that you could get that much medical supplies in. So does everyone understand how this app works? Basically, you feed in a patient's data, this thing would spit out how much money is this person going to probably need, so that you would make sure to have enough equipment on site that you could help this person out in the long run. Does all that make sense? So, can you guess how they assessed how likely it was that this person was going to need health care in the future? What sorts of data got fed into it? There were a lot of different things, but let's see if we can come across the one that ended up being a problem. So if you were designing this program, what are some of the things that you would include in here to judge how healthy a person is and how likely they are to need health insurance, or health coverage, I mean? Medical history, so that would be one, but what sorts of things would you especially highlight? Like what, not just entirely their medical history, but like if you were designing boxes of like, they did this. So past illnesses, so you'd include things like what their past illnesses were. And along with that, what else would you put in there? Like what other sorts of information, along with what the past illnesses were, what else would just go in there? Not just what they were, but so if this person came in last year with measles and the year before with mumps and the year before with chicken pox and all of this, as well as putting all the things they had, what all are you going to put in to this little program? So how susceptible they are, and how would you judge how susceptible they are? Because you can't just like stick a needle in someone and have like a susceptibility score come up. How would you judge how susceptible they are? How often they get sick, and how would you judge that? You could ask them, but that information, not many people are going to pick up their phone. So how are you going to judge how often they get sick? You're along the right path here with how often they get sick. How, though, can you judge how often someone gets sick? Or more importantly, how do you judge how often someone gets very sick very often? What's something that you could use to come to this conclusion? Number of hospital visits or number of doctor visits? So yeah, basically, in a perfectly reasonable way, one of the things that was included in this, how likely is this person to end up needing medical attention, was how many times in the past 10 years did this person go to the doctor? Or how many times in the past 10 years did this person go to the hospital? Which is a reasonable way of thinking, but this led to a major problem. Because as well as being sick, what is another factor that affects whether or not you go to the doctor? Like you only go to the doctor if you're sick, but every time you're sick, you don't necessarily go to the doctor. Why might you not go to the doctor even if you're feeling pretty shitty? So one would be the common cold, so it's not that big a deal. But what would be another reason that you, even if like you've been throwing up for 3 days and you think maybe you should go to the hospital, you don't go? What would be a reason not to go in that case? No insurance is the main one of medical bills and no insurance. So the fact is that the more often people go to the doctor, Generally speaking, on average, who goes to the doctor more? Wealthy people or poor people? Wealthy. Why? Because they can afford it more. So even if people who are poor are less healthy because they have like less healthy food in their system, they go to the doctor less because if you have less good insurance or no insurance, you can't afford to go to the doctor. So basically what this company did was they designed an AI program that was designed to highlight how much medical care is this person going to need. But built into their formula, somebody discovered if you put two people into the system with the same medical history, and yet one was a person of color and one was white, very often it was saying that the white person was going to need more money put aside for them. And the reason why was because the white person was generally more wealthy because of socioeconomic reasons and history, and would go to the doctor more often. And this AI program was spitting out this person is less healthy, when in truth, these two people were equally unhealthy. So in this way, this human who couldn't recognize everything started making this program that basically said white people need more doctor attention than black people. And this came out because of this sort of just, it was not intended to be racist. It was just human beings have biases, have blind spots. And once you build it into the AI program is now spitting out these conclusions like black people set aside $5,000, white people set aside $7,000. Does that make sense about how we got there? How you end up with a racist AI program being designed by human beings and leading to unequal medical care from this perfectly reasonable sort of like set of thinking that comes out by the fact humans are biased. Does that make sense to everyone? And again, you can start to see now why AI, while very good, can also be concerning. Another one that really shows this exact same thing. Are people familiar with the US News and World Report college rankings? Have people heard of these silly college rankings? Basically, they come out every single year and they just say like, this school is like a 96 and this school's an 85. And so every year colleges want to advertise how well they did. So they put on their US News and World Report score. Are people familiar with this stupid thing? Have you heard of it though? Like, I don't need like the details. It's basically just like a way in which like the very fancy schools get to pat themselves on the back about how good they did, even if the education is not that different. So basically the idea of these college rankings is that they are supposed to show you how good of an education you're going to get in college. Now, basically they have an AI program where you put in a whole bunch of information, things like graduation rate, future income, all this different stuff. And it's supposed to say, if you go to this school, you'll get a high score. Now, imagine you were a dean and people care about these scores. Like these scores have real world effects on if you go to, like, the shitty fact of the matter is in some circles, what school ranking you had will determine whether you're taken seriously for a job. Like that sort of shit is real and it's fucked up, but it matters. And this is why this is why there was that SAT controversy in which wealthy people were paying $10,000 to get fake scores for their kids, because going into these fancier schools can make a big difference long term. So now imagine the following case. Imagine you as a college are given $50 million by a wealthy donor, and you are told, invest this $50 million into your school with the #1 goal being to raise your new US News and World Report ranking. And the US News and World Report ranking is supposed to capture how good of a college you are. And you want to go up the rankings. You are, say, a college rank number 75 and you want to go up to 50. Where should you put this money? If you are the company, or if you're the head of it, you're like the president of this college, and you're deciding where to put this $50 million. And this $50 million is designed to raise you up the rankings. And the rankings are in theory supposed to say how good of a school it is. Where do you think is the best place to put the money? Where would you put it if your goal was, there is a right answer, and I want to see if anyone can guess what it is. So one would be to bribe the people, but they're actually like, you know, they're honorable people to some degree. So you can't bribe them. So imagine not bribable. If they're not bribable, where else might you put it? Would you put it into how nice the gardens of the schools are? Would that make you go up the rankings? No, you wouldn't put it into the gardens. That's not going to make you go up the rankings. Where might you put it though? So Kevin got to the right answer. Sports. The correct answer is the athletics department. That is actually the right choice. Now, why on earth would a better school, like how many of you think that the number one key to your education and the quality of your class is the sports teams that your school has? How many of you consider the John Jay sports department the number one contributor to how much you learn in a day? Yeah, last thing on your mind, to be honest. And Scott, that's the last thing on my mind. The thing you'd think of are teachers. You'd think of class size. You'd think of financial aid. You would never think that you'd put it into the sports department. But in truth, putting it into the athletics department is the number one best way to raise your ranking. Why? Well, because of the nature of the AI program. The AI program, one of the things it takes into account for how good of a school it is the acceptance percentage or the acceptance rate. Now, generally speaking, a school that is very good is going to be harder to get into than a school that's not very good. Like, that's just the way that it is. To get into Harvard is hard because of the fact that people worldwide want to go to Harvard, which makes it very difficult to get into. So does all that make sense with acceptance rate? So built into this AI program is basically the lower the acceptance rate, the higher score you get in the rankings. One weird thing though is, many of you went to school recently. You might be freshmen, you might be sophomores. Even if you're a senior, it's still only been 4 years, or even if you're a returning student, it's probably within the past 15, 20 years. When you were 18, myself included, we all have different values. And when you're 18 years old, a lot of people want to go to a college that has a really good sports team so that they can cheer on that sports team. So very often, the better a school's sports team, the more people apply to that school in a year. And the more people who apply, if say you accept 2,000 people one year, and then out of 10,000 applicants, and the next year you're still only accepting 2,000, but 15,000 people apply, your acceptance rate has gone down significantly. Therefore, that will shoot you up the rankings. Even if the reason that more people are applying is because your sports team is good. So this thing, which was designed to capture how good a school is at giving you an education, is getting majorly flawed by the ways in which acceptance rates are affected by things like sports teams. So engineers being human means that there can be biases built in, and there can be things which can cause so it's not, they can cause biases, and there can be blind spots, which end up with these AI programs tracking things different than what they were originally designed to track. You can end up, when it's an AI system making decisions, it's very easy to game the system once you know how the AI program works. And that can lead to a lot of very strange, unsuccessful outcomes. And you end up with things where you have a ranking that is claiming to tell you the best colleges, which clearly is no longer giving you the best colleges. Does that make sense to everyone as well? This is the second sort of problem that comes from the engineers being human. Three, the third issue with this is So the third issue with AI software is that it can be used for problematic purposes. And by problematic purposes, what I mean here are AI programs that make decisions on topics that you wouldn't necessarily want an AI making decisions on, either because this AI program is learning things about you that you wouldn't want it to learn, or because this AI program is being used for some social purpose or economic purpose or political purpose that you would not want an AI program designed to do. So I want to finish this class off by talking about two different cases in which these AI is being used for more problematic sorts of issues. The first one I'm going to talk about is Target, and the second one is the Chinese social credit. So the Target case. Does anyone know, either had an opportunity to do the reading or was familiar with it? Why is Target up here? What was the case involving Target and data mining AI programs, decision making with AI, that is leading to Target being up here as the problematic purposes case? Anyone know? All right, I'll give you a clue. It has to do with babies. Target and babies. All right, here's the thing. How many of you, I'm not going to ask who has kids or anything like that, but if you have kids or if you've had a kid, how do you want your parents to find out that you were pregnant? Or your partner was pregnant? How would you want that information passed on? You'd want it as a surprise, or at the very least, who do you want them to find out from? Yeah, you want them to find out from you. You want to tell them. If you are 1 month pregnant, do you want everyone in the world knowing it if you haven't told anyone yet? Or do you want to have control over who finds out that you're pregnant or not? Yeah, you don't want everybody to know. Like, eventually, if you are a female and you are 9 months pregnant and people are interacting with you face to face, eventually someone's going to come out. But you don't want everyone knowing everything about you straight off the bat. So you want some control over things. However, why am I bringing up Target? So Kevin had an oh wait moment. Does anyone else know what I'm talking about here? Yeah, basically here was what Target did. Whenever you walk into a Target store and buy something, you have a customer ID number. You basically have a number that is queued up to your credit card so that anytime that credit card gets used, it stores everything you buy on this number. It won't it's not, your credit card number is not stored in the database. It's rather that when the credit card swipes, that links up, say your number 1000, then anytime this credit card gets used, account 1000, it puts in what you bought. It'll put in, say you bought hand sani, and it'll put in things like the time, it'll put in the amount of money, etc., etc., etc. So does that make sense? Like, every time you buy from a store, it gathers this information. Each individual purchase, everything about you. And it does this for everyone who ever walks into the store. 1001 will have that. 1002 will have that. So you can see how over time, what they're going to have is a huge database on all of their customers' purchases across the past 15 years. So it's just a gigantic, gigantic data set. Exactly the sort of thing that you could do data mining on, and then use an AI program to spit out information about. So, does all of this make sense? Now, how many of you have signed up for a newsletter or something to send you coupons? How many of you have ever signed up with your email address to, like, I'd like, you're a big baseball fan, so you sign up to tickets, like cheap tickets, or you are interested in Marvel comics, so you want the newsletter that announces whenever a new comic is coming out or something like that. Or you're really interested in sneakers, so you want the newsletter, or you want to get the Foot Locker ads whenever they have deals on sneakers. Anyone follow any of the? I'm sure some of you follow some of these sorts of things. Now, that same information will also be added to your thing. So it'll include all your purchases, but it will also include what your email is, and it will include whether or not you have registered. Like if you've registered, if you're on like Foot Locker and you've registered for the Nike information, then it'll include like Nike subscriber. Now in Target, one of the certain things you can sign up for is an expecting mothers newsletter or expecting mothers advertisements or coupons. Why would an expecting mother want to get emails from Target? What would these things be advertising? What coupons would you be getting? Right. Yeah, coupons for diapers, coupons for what else? Formula, baby food, that sort of stuff. So yeah, it will also include such things as, so the Target one would have your hand sanitizer, blah, blah, blah. It would also include, are you on baby registry? And when you signed up for the baby registry. So people are only going to sign up for the baby registry if they're pregnant or they're planning to become pregnant. So what was Target able to do? What Target was able to do was basically they threw out every customer who wasn't on the baby registry. And then they had a computer analyze what were the people on the baby registry buying. And what they started to find was that based on who was on the baby registry, you could begin to see certain patterns within their purchases. So for instance, somebody who is 9 months pregnant, had been on the baby registry for 9 months, was all of a sudden stocking up on diapers. That makes sense. They were stocking up on formula. That makes sense. They were stocking up on baby wipes. That makes sense. But what was more interesting is that Target started realizing that people who had only recently started registering for the baby registry were also purchasing things slightly different than before. So for those of you who have never been pregnant or are men and before they read this story didn't know this thing, when a woman gets pregnant or when a female gets pregnant, a lot of hormonal shifts happen. And one thing that can change is sensitivity to certain smells and tastes. So there's often a case of somebody will suddenly start having food cravings that they've never had before, or smells that they used to like will suddenly become overpowering. And one thing they found is that at about 2 months into the pregnancy, or 2 months after this woman signed up for the baby registry, all of a sudden there was an increase in unscented hand lotion. So somebody who had previously bought a lot of scented hand lotion, at about 2 months after being on the baby registry, started buying unscented hand lotion. And things like candle purchases started shifting, and other sorts of things happened. And what Target basically was able to do was start to look for patterns within people in the baby registry to identify what people on the baby registry were interested in buying. Now, what could Target then do with this information? And what did they do with this information? Once you know what sorts of, let me erase all of this. You've now identified if pregnant, then buy X, because people on the baby registry were buying these things. Or if 2 months pregnant, you tend to buy these things. What could Target now do with this information? That if at 2 months pregnant, you started to buy these things. Why is this information useful to them? Well, imagine that you had somebody walk into, so let's say this is unscented hand lotion, ice cream, and I don't know, Crest toothpaste. Say they, by looking at this, they've discovered that when women are 2 months pregnant, there's a pretty high chance that they're going to buy unscented hand lotion and ice cream and Crest toothpaste. Now, you see somebody go onto the online store, the online Target store, and go into their basket. And in their basket is unscented hand lotion, ice cream, and Crest toothpaste. What can you now as Target guess about this person? You don't know anything about them. They're not on the baby registry. It's just this was in their cart. What can you now guess about this person? Think about it for a second. If you know that 2 month pregnant people tend to buy these things, then what might you guess about this person? That this person might be pregnant. And now, once you know that this person might be pregnant, if you know they're pregnant, what sorts of things are they going to start wanting in about 2 months' time, 4 months' time, 6 months' time? What are they, if they're 2 months pregnant, what are they certainly going to want in 7 months' time? More baby stuff. So before they do not have to tell you that they are pregnant. Rather, based on what they've been purchasing, you are able to identify that they are pregnant and start catering your things to them. So the famous case of this is a girl 16-year-old girl went to Target and bought some things. A week later, she got a little message from Target that said, "Congratulations on your first child. Here are some coupons." Her father found this and freaked out from Target and was like, "What are you doing trying to make my daughter pregnant?" He then, Target, like HR or Target, I guess it would have been their publicity team, called him up and was like, "We are so sorry about this." And then they followed up a week later to be like, "We're still so sorry." And the father said, "Actually, I had a talk with my daughter. Turns out she is pregnant." So Target identified this 16-year-old girl was pregnant and outed her pregnancy to the father based on this purchasing history. How many of you are comfortable with this idea that based on what you're buying, Target is able to identify whether you're pregnant or not, whether you have a certain illness or not, whether you have certain phobias or not? This is the sort of stuff that Target is able to do. And is there anyone who's just like, "Nah, I don't care"? If so, you're a braver soul than me. But most people are not comfortable with this. So does anyone know what Target started doing? They found out people didn't like getting these "congratulations on your first child" stuff. So what did they start doing? Did they stop doing this data mining? Did they just stop completely and go? No, they did not, Sean. What did anyone guess what they did do? So they now know you don't like it. They just stopped telling them exactly. You no longer, this is what Target does now. If they identify that you're likely to be pregnant, they will send you a coupon book that has all the things that you would want as a pregnant person, but they hide the coupons in amongst a bunch of things they know you wouldn't give a damn about, so that you don't know that they know that you're pregnant. So they'll have the diaper coupon, but right next to it will be like a chainsaw, and right below it will be like a basketball. And so they know you're not interested in the basketball. They know that you don't give a shit about the chainsaw, but they know that you're going to want those diapers. But they don't want you to know that they know that you are going to want the diapers. And so this is the way in which the fact that this data is being collected about you and then mined, you are now being manipulated into buying diapers from Target, but it's being presented to you in a way that you don't know that Target knows that you're pregnant. Does that all of that make sense to you about how this gets done now? And so and to be clear, like every company does this. Every large company is doing this all the time and running data mining on every purchase you make and any other member or any other customer has ever made. And from this, they will then send you targeted ads. They will send you slightly less than targeted ads. So this is the sort of thing. And when you start breaking it down, this is where the lack of privacy takes us. The lack of privacy takes you to this point of it's not that they are targeting you because of what you did or following you. It's rather that they are using the data that's out there about you, comparing you to other people, and then using that to get ahead and present you with things that you might be more likely to purchase. And as we said a few times ago, this can be like very beneficial. If you're a new mother who doesn't know some of the things you need until they're presented to you, it will have benefits, but it's got a flip side as well. All right, to finish, let's talk about the social credit system. What is the Chinese social credit system? It is not fully implemented yet. It is just on its way to being implemented. Does anyone know what this is or how it works? Okay, so you saw with these data mining things, how the more data you have about someone, the more you can draw conclusions about them and use this in an AI program to spit out a decision about the person, right? That all made sense. The bigger the data set, the more you can do with that data. So the basic idea behind the Chinese social credit system is what happens if instead of Target having one database about you, the New York City government having a database about you, John Jay having a database about you, what if there was a single database that included every piece of information in every aspect of your life? So you've got your travel history, your shopping, your school records, including your disciplinary records, any online presence you have, so anything you say on social media, any website you have, anything that you have, any criminal record, anything you've said, or let's see, school records, criminal records, health stuff. Let me think. What other sorts of things do they have? Purchase, yeah, we got shopping, job history. And imagine if all of this was stored in one place. Now, not only this, then based on all of this stored in one place, you are then given positive points for doing good things and negative points for doing bad things. And you get a score at the end of it. So if you jaywalk, you start with, say, 1,000 points. And if you are caught jaywalking, it's -2. And these days in China, jaywalking is done with facial recognition. So just on every street corner, there's a camera, and that camera scans your face, and then you'll get a ticket for jaywalking. So you get -2 for every time you jaywalk. If you do something unhealthy, so for instance, playing too many video games is deemed unhealthy and problematic, -10 points. And they'll know what because your computer record is hooked up. So if you're playing 6 hours of video games, the government can now know about it because that's stored in the same database as everything else. If you keep breaking the same leg over and over again, that'll be -6 points. Then say you give to charity, that'll be +4 points. Say on social media, you criticize the Chinese government, that's -500 points. Now you'll start to see you're by the end of this going to have a score. Let's say your score is now 56 points because you did a lot of bad stuff. Now the government, this information will be available to various people who might want to get this. So if this is public, the goal would be you look, see this person has a 56 social credit score, we're not hiring them for a job. If you have a 56, you aren't allowed to get a passport or something like that. If you're a 56, you aren't allowed to get certain types of loans. This is what the social credit system is. It's not fully implemented, but this is the ultimate picture of how it's supposed to work. Your entire life, everything you do being stored in a single database, and then spitting out a single number that determines how well you are deemed an acceptable member of the society. And yeah, as Scott says, this sounds like something straight out of a movie. And to be clear, this level of the social credit system is not nearly up and running yet. At this point, there are several private ones that are set up in specific areas. So like a certain government organization will have one. And so like within your job, your company will have a social credit system. So if like you're late to work a lot, your score will go down. But the worrying thing is, what if all these private company social, like inner social credit scores start being shared with the government, who then does combine it with your criminal record and everything else? And so you can start to see how this sort of thing, this is like the ultimate like dystopian world in which data mining leads us, is the social credit system in an extreme sense. And this sort of thing is really like the jumps from where we are today with big businesses and all of this data is not that far away from a complete social credit system. The difference is in this country, it's not going to be the government with all this data. It's rather like Amazon. Think about how much Amazon has about you. If they can use all of this and give you a score and then deem how, and this is the sort of thing that Amazon does do with their workers. You get a worker score, and if you don't meet certain criteria, you will get fired from your job. And it'll be things like, how long are you in break? Are you on time? Are you this? Are you that? And it all gets automated. And these sorts of things are not going to be, like, you cannot appeal to your supervisor that your child was sick. You have a certain thing, your score went down, that's the end of it. So this is why I think privacy is worth talking about, because in a certain sense, all my data being out there is not directly threatening me. It's rather that all my data being out there contributes to this giant system in which all your data being combined with everybody else's data is allowing companies or governments to make decisions on a very large scale that is not individually suited to you and your particular situation, and can ultimately lead to things. And I was reading it in the reading, one of the guys was saying that basically, if your social credit score is low enough, in certain regions of China have it in place. And this guy had written, he was an investigative journalist who had written some things against the Chinese government. And it was basically like, this guy could now, there was nowhere really to go. His score was low, and there was basically nothing he could do except he was never going to be traveling to certain places because he couldn't change the score, because it's just this giant mechanical system. All right, I'm out of gas. Does anyone have any questions, comments, concerns, feelings about any of these things? Anything we talked about today? We all doing all right? Yeah, these sorts of social credit systems are really kind of dystopian and scary. And we don't know how far it's going to go. Like, it could end up being not that threatening, or it could turn into the full Chinese social credit in like the envisioned dystopian, straight out of Black Mirror sort of way. All right, so I know some of you came in late, so I want to repeat what I talked about at the start of class. If anybody is, if anyone was here and doesn't care about the paper deadlines, feel free to go. Have a great weekend. For those of you who came in late, I'm just going to say again, Thursday the 28th, end of day, is when paper 1 is due. Again, if you need an extension, just ask. 8 a.m. on Tuesday the 26th, 8 a.m. Tuesday 26th. This is the time that if you want comments on a draft, I need your draft by. This is a hard deadline. So this one you can't Like, because this is just like it's not mandatory, it's just if you want comments on any sort of draft, then you need to make sure you have your drafts into me before this time. I will give you full credit on it. You're good to go. Then the paper itself is due on the end of the day on the 28th. If you turn in a few hours after that, don't worry about it. And then if you need an extension, just ask me about it. All right, everyone good? The paper is 3 to 5 pages, Rebecca. But as I said at the start of class, the other thing, that 3 to 5 is suggested. This is, generally speaking, if you write a paper that's under 3 pages, it will be not enough detail to argue well. Generally speaking, over 5 pages is generally because someone is rambling or repeating themselves. However, I have gotten good papers, like A papers that were under 3 pages, and I've gotten A papers over 5. So don't panic just because you're under or over the limit. Just ask yourself, am I under the limit because I'm not saying enough, or am I under the limit because I wrote a really concise, great paper? Same thing. Am I over the limit because I wrote too, like, am I just repeating and rambling, or am I over the limit because I covered everything perfectly? Either one, don't worry about it. If, however, you find that it's too short because you didn't say enough, add some more. If you are over because you're repeating yourself, cut something out. So aim for 3 to 5, but don't stress about that number too much. It's not a hard number. I will never take off points just because it's too long or too short. All right, everyone good? All right, have a good one, everyone.